If you take the displacement reaction, in that we have to observe which we have to observe the nature of that element present in that compound or the element which is present in an isolated state. For example, suppose I want to treat the zinc metal, zinc with the copper sulfate. The color of the copper sulfate is blue. Okay. So among this zinc, iron, copper. Okay. Among these three, the zinc is more reactive than iron. Iron is more reactive than the copper. That means among these three, the copper is less reactive. Okay. So this zinc, the symbol of zinc is Zn plus CuSO4. Okay. So this copper present in the salt, its salt solution. Okay. Copper is present in its salt solution. So the zinc has a capacity. Or ability to displace the copper from its salt solution and get its place. Okay. Suppose this zinc can change the place of this copper. That means when it replace it remove it, then we get the ZnSO4. Then what is happen? This copper become free. And copper will settle at the bottom of the container. Okay, and this blue color of the copper changes to colorless solution of zinc sulfate. The solution turned from blue to colorless, that indicate the reaction takes place, the displacement reaction takes place, and the displacement reaction takes place in between zinc and copper, and the zinc sulfate is formed. So here the zinc has more ability, is more reactive, you can say, than the copper, so it can displace. Okay, suppose if you take the reverse reaction, for example, suppose ZnSO4, then Cu, ZnSO4, then Cu. This Cu treated with the zinc sulfate, then this Cu don't have ability or capacity to remove this zinc, so this reaction will not take place. Okay, because this is less reactive than the zinc. Okay. I will take another example. Suppose in a beaker I have taken the blue color copper sulfate solution. This is blue color copper sulfate solution. Okay. I put one iron nail in that. This is the iron nail. So my reactants will be Fe, that is iron, and copper sulfate. So here the iron has ability to remove this copper from its salt solution. Then we will get FeSO4 plus Cu. Okay, that means the displacement reaction takes place here. Okay, so you understand these two examples and also understand the displacement reaction. Then I hope that you recall all the three reactions, okay, with examples. Then fourth, that is double displacement reaction. Okay, double displacement reaction. Here, double displacement reaction. The name itself indicates that the two different salts are involved. For example, I have a Na2SO4, that is sodium sulfate, a solution of sodium sulfate. I treated this sodium sulfate with the solution of barium chloride. Sodium sulfate, barium chloride. Sodium sulfate, barium chloride. Then this double displacement reaction takes place in between these two chemical compounds. Okay, this sodium will go to this place of Ba and Ba will go to here. Then our product will be BaSO4, barium sulfate, and NaCl. So here the Na two atoms are there. I have written only one atom. In sodium chloride, chlorine there are two atoms. I have written only one. So I have to put 2 as a coefficient or multiply this NaCl by the 2. So now this reaction is balanced. So when sodium sulfate react with the barium chloride, we get the barium sulfate and sodium chloride as a product of double displacement reaction. Okay? Now our last reaction, that is the redox reaction. That is redox reaction. So redox reaction, actually there are two types of redox reaction. That is oxidation and reduction. These two states are involved in the redox reaction. Sometimes only the oxidation takes place and sometimes only reduction. But in so many cases, the both oxidation and reduction reaction take place in the same reaction. Okay. So before that, we should know the meaning of oxidation. Okay, very important term in the chemistry. There are different definitions. The first is that oxidation means the loss of electron by that element. Okay. The second is the addition of oxygen is called as oxidation. The third is that removal of hydrogen is also called as oxidation. Okay. So loss of electron. For example, the sodium remove its one electron and form the sodium positive ion. Okay. So here the oxidation of sodium takes place, we can say. Okay. Magnesium remove its 2 electron and form the Mg dipositive plus 2 electron it form. Okay, that means here the formation of Mg dipositive from magnesium, formation of sodium monopositive ion from the sodium called as the oxidation of these elements. Okay, so according to this first definition. Then addition of oxygen. For example, magnesium react with the oxygen, we get the magnesium oxide. Here the oxidation reaction takes place. Addition of oxygen in the magnesium. Okay. And the third is that removal of hydrogen. That's in some reaction the hydrogen. If we remove the hydrogen, then it is also called as the process of oxidation. So opposite to that oxidation, the definition for the reduction. Okay, reduction reaction. That is opposite to that oxidation. In oxidation, loss of electron. Here, the process in which there is a gain of electron takes place. Okay. Then addition of hydrogen is called as reduction, or removal of oxygen is called as reduction reaction. Okay, for example here the Cl chlorine wants 1 electron to, okay, then it accepts the 1 electron from other element like sodium and form the Cl minus ion. So reduction of this chlorine takes place. Okay, then addition of hydrogen, then removal of oxygen. These are also two definitions for the reduction reaction. For example, so CH3 CHO plus there is the addition of hydrogen. So I am taking this example from the organic chemistry. When the hydrogen gas is treated with this acetaldehyde, we get CH3 CH2OH. Okay, so here CH3 CH, to this carbon only one hydrogen, but now here the 2 hydrogens are there. Again oxygen was single here, oxygen is connected to hydrogen, that means 2 hydrogens are added here. So this reduction takes place. Okay. Similarly, the third definition, that is, if there is a removal of oxygen from the reactant, then it is called as reduction. So Now we will take the combined example for the redox reaction. Okay, in the redox reaction, simultaneously both oxidation as well as reduction takes place. For example, when we treated this copper oxide with the hydrogen, then what happened? Then we get CuOH then we get Cu plus H2O. Then we get Cu plus H2O. So here the copper oxide treated with the hydrogen gas. Then what happened? There is a removal of oxygen. Okay, that means reduction for this copper takes place, and there is a addition of oxygen to this hydrogen and formation of H2O. That means the oxidation of this hydrogen can say takes place, and the water molecule form, and the copper become free. Okay, so this is the example for the redox reaction. So I hope that you understand all the type of reaction. Now this is the time for the homework. Explain combination reaction with suitable reaction. What is balance chemical equation? Okay, so dear student, these are the two questions for the homework, and you do your best. You read the textbook and enjoy the lesson. Thank you.